Alright, let's look at the homework 4.3, problem number 6. Alright, so we want to find the interval of increase and the interval of decrease of this function c of x. Alright, so let's do that. Alright, so we need to take the derivative. So let's take the derivative. C prime of x is equal to, so derivative of the first guy, so I'm using the product rule. 1 over 7 x, and subtract 1 from the power, so it's negative 6/7, right, times the second guy, which is x plus 8, plus the first guy, x to the 1/7, and then multiply by the derivative of x plus 8 is just 1. Alright, so we have to, let's rewrite this guy. Alright, so 7 is sitting on the bottom, and x to the 6/7 is sitting on the bottom, since it's a negative power. Then we have x plus 8. Alright, so if we take the common denominator, so I'm going to multiply top and bottom by 7x to the 6/7 power, so I'm going to take the common denominator. Then you have a 7, and you have x to the 6/7 times x to the 1/7 is going to be just the x, right? So this is going to be actually kind of nice, 8x plus 8. So I'm going to actually pull 8 out, and x plus 1. Because this is 8x plus 8, and over 7x to the 6/7 power. Alright, so we set that equal to 0, and we can see that we can set numerator equal to 0, so x equals -1 is one critical number. And also, since c prime of 0 is undefined, so this will make 0, x equals 0 is another critical number. Alright, so we're going to do a number line. So here's a number line. Then I'm going to put 0. And actually, maybe I should put the -1 first. -1 and 0. Right? Then we're gonna look at a sign of c prime. Right? So here, when x equals -1, c prime is 0, and here it's not defined. Right? So c prime, so we can try any number less than -1. So I'll try -2. Alright, so if you plug in -2 in here, right, on the bottom, because of the 6th power, so negative sign is gone, so that's positive, but the -2 plus 1 is negative, so it's going to be negative here. Alright, between -1 and 0, so I'll probably try x equals -1/2. Right, and -1/2, that's going to be positive, and this is going to be positive, so everything is positive here. Right, anything bigger than 0, so I'll try 1, and that's positive, everyone's positive. Alright, so looks like we have, increasing on interval between -1 to 0, and also 0 to infinity. Right, so it's going to be, I'm gonna write -1, and I can probably include this -1 to 0. Alright, and let's see, so derivative is not defined, but actually I can include that. And then interval notation. What should I do? it's still increasing. So I'll probably do this. Let's see. Alright, I'm gonna just say it goes to infinity. Alright, because you start from 0, so it's increasing here. And even though derivative's not defined, it's still increasing. So I have a feeling that you're going to have a vertical tangent line here, and I keep on going. So actually, so it's increasing all the way, right? How about find the interval of decrease? So it's going to be over here. So it's going to be negative infinity all the way to -1. Right? Find the local minimum values. Right? So if you look at the C, and the behavior of original function would be decreasing here. After that, it's increasing. So it's going to be a local minimum value at -1. Right? So here, oops. Maybe I should use a different color. All right, so you have local minimum here. All right, so we can, let's see, minimum value. So that would be C of -1. So C of -1 would be, right, -1 to the 1/7 power is negative, right? -1 plus 8 is 7, so it's -7. Alright, and the local maximum value, alright, so local max value actually, let's see, here's the minimum, and it's going to going up, and so there's none, so it does not exist. Alright, so let's type those guys in before I forget. Alright, so it was -1 to positive infinity. Alright, and I think I can put the bracket there. And here, negative infinity to -1. Right, and to find a local minimum value, that was -7, and local maximum value does not exist. Right, and we want to find the inflection points. So let's do that. Alright, so find the inflection point. Oh, actually, before we do that, maybe make sure that I got the right answer. So I'm going to just submit for testing. Alright, looks like we got the first two parts correctly. Alright, part A and part B. Alright, so let's do part C. Alright, so we want to find the inflection point. So we need to take the second derivative, so another derivative. Right, so C double prime of x, right, so that was the first derivative. So 8/7 is just a number, so I'm going to just put it here. Alright, then product rule here. Alright, take the derivative of the first guy, so you're going to get the negative 6/7 x to the subtract 1, so it's a negative 13/7. Alright, times x plus 1 plus, alright, keep the first guy, x to the negative 6/7, right, then multiply by derivative of the second, it's going to be 1. Alright, then we just have to rewrite this guy. So let's see, 8/7 is still out there. Alright, so this guy is, let's see, negative. Alright, -6 sits on top, and 7 sits on the bottom. So x to the 13/7 sits on the bottom. Then you have x plus 1. Then here, taking a common denominator, so we're going to multiply top and bottom by 7x to the 13/7, so 7x to the 13/7, and then if you do that, you're just going to get 7x, right? Because 13/7 minus 6/7 is 7/7. All right, so we get that. All right, then we can just compute this. All right, so we're gonna get this. All right, so 8/7 just sits there. All right, 7x to the 13/7. All right, so we have a negative 6x plus 7x, so it's just going to be x. And negative 6 times positive 1 would be negative 6. All right, so if you set that equal to 0, all right, so you can see that, let's see, you're going to have, let's see, x equals 6 is one of them. And also derivative, second derivative doesn't exist, so we have to look at the x equals 0 as well. Right? Then we look at the number line again. Right? This time we're going to use 0 and 6. Then you look at the sign of C double prime. Right? Alright, so we try something, let's see, less than 0, x equals negative 1. Alright, so if you put negative 1, so negative minus 1 minus negative 6, so that's negative. Alright, negative 1 to the 13th power is going to be negative, so a negative divided by negatives is positive. Alright, anything bigger than 0, less than 6, about 1. 1 minus 6 is negative. That's going to be positive, so it's going to be negative here. Anything bigger than 6, I'll try 7. So that's positive, so we have a positive there. Alright, so looks like we're going to have inflection points here, since concavity is changing. Also, inflection points there. Alright, so smaller x value is 0, comma. And the corresponding x value, we plug in 0, it's going to be 0. So that's the origin. And also, when x equals 6, right? So you're going to have, let's see, that's going to be 6 plus 8 is 14 times 6 to the 1/7 power, right? So that's that. And the interval where the graph is concave upward, so that's going to be negative infinity to 0, and 6 to infinity. Concave downward is between 0 and 6. Right, so let's type it in. Right, so we found that it's a 0, 0. And second point was 6, 14 times, let's see, to the 7th power. Let's see. Oh, that's not what I wanted to do. 1/7th power. Alright, 6 to the. Right. And then interval is negative infinity to 0. And set union, union 6 to infinity, and this is between 0 and 6. Right, so let's check. Submit for testing. Alright, I came back and we got all of part C correctly. Alright, that's it. I hope that this was clear.